Hello everyone, welcome to this session on units and dimensions. We are also going to solve previous year's JEE Mains and even JEE Advanced questions. In this session, we are starting off with units and dimensions, and as you can see, the first topic we are covering is physical quantities and system of units. We'll try to understand what physical quantities are as opposed to, let's say, abstract quantities. A physical quantity is anything that can be measured. We can put a number to it, like the length of something, the length of a table, or the weight of something, mass of something, okay? Things like these. So we can put a number to these things. As opposed to it, we have abstract quantities. Abstract quantities like love and hate, we can't measure it, okay? We can't say, I love someone 20 units or I hate you 25 units. I mean, that's absurd, right? We cannot measure it, we cannot put a number to it. So, physical quantities are those quantities that can be measured, and they can be quantified. By quantified, we mean we can put a number to it. So, if I want to measure the length of a table, this is the length. I use a scale to measure it, or whatever measuring instruments we have. We measure it and we can say, okay, the length of the table is 20 units. This is the next thing we're going to see. What is a unit? Now, a unit in simple English means one. Unit means one. Okay. So, what is the smallest measure we are using to quantify this length? So if we're considering how many centimeters are there, yeah, this can be, let's say, 20 centimeters. So centimeter would be the unit. To define it properly, you can call a unit to be a well-defined, a very well-defined standard amount by which we are measuring this thing. Okay, some standard units are things like centimeters, meters, kilometers for length. Some non-standard units would be, let's say you take this pencil for example, yeah, and you start measuring the length of the table using this pencil. So what you'll do is you'll say, okay, the length of the table is, let's say, two pencils. So this is the unit in this case, yeah. But this is not a standard unit because at every at a different location, the length of pencil might be different. If you've used a pencil and you've sharpened it, the pencil length becomes shorter. So using this is not a good idea because at different places the pencil length will be different. So we can't give a unique number if we are using this non-standard unit. So that's why we have defined certain units and we call it standard units. The definition for these units, I'll put it on the screen. You can go through that. And these definitions are accepted throughout the world. So that's the interesting part about standard units. Now, I hope you've understood what are physical quantities and what are units. Unit is the smallest standard amount, whereas a physical quantity is anything that we can measure. Area, weight, mass, force, all these things are physical quantities, as opposed to abstract quantities, like we saw a few examples. Now, let's see what are the different types of physical quantities. Physical quantities are broadly categorized into three parts, okay? One, fundamental quantities, then we have supplementary quantities, and the third one is derived quantities. We'll learn about derived quantities a little later. For now, we'll just let it be. Let's focus on fundamental quantities. So, initially, different places they were using different kinds of units. Okay, so in United Kingdom and other places, metric system was being used, whereas in US we had the foot pound system. So in US people used to measure length using foot, weight using pounds, whereas the same thing was measured in terms of kilograms in the United Kingdom, India, and other places. Yeah. So, fundamental quantities are those quantities which do not depend on other quantities. Okay, so a bunch of people came together and they decided, okay, these are our fundamental quantities. So, all the quantities we see, we have around us, all the physical quantities, they can be expressed in terms of these fundamental quantities. Consider these as the building blocks of measurement. Yeah. So, what are those building blocks? We have length, we have mass, we have time, we have electric current. So, all the things relating to electromagnetism, they would require electric current to be expressed. Then temperature. So, when we dive into thermodynamics, we would need this fundamental quantity. Luminous intensity, amount of substance, which is mole. Yeah. So these have been considered as fundamental quantities. Now remember, the list of fundamental quantities wasn't always this long. Initially, we considered only three quantities to be fundamental. They were length, mass, and time. Now, as and when new discoveries were made, we got to know about new physical quantities, we thought, okay, these three, length, mass, and time, are not sufficient to express this new physical quantity. For example, electric current. So then we included something else in the fundamental quantity, or even voltage. How do we express voltage? And that's how more and more items got included in this list of fundamental quantities. At this moment, right now, we have seven fundamental quantities, yes. And the rest of it is derived. The rest of the quantities are called derived quantities. There is something called the supplementary quantities. So, supplementary quantities are those quantities which do not have any dimensions. Now, these are quantities that we couldn't put in the category of fundamental quantities, and we couldn't put them in the category of derived quantities also. The reason being, these are not fundamental quantities because they are derived from the fundamental quantities. For example, plane angle. We know angle is defined as arc length for a circle, arc length upon the radius of the circle. Yeah. Now, arc is also length, radius is also a length, a different kind of length. So, angle is a dimensionless quantity. Similarly, solid angle is a 3D angle. This is also a dimensionless quantity, and we couldn't place them either in fundamental quantities or in derived quantities. That's why we created a new category called supplementary quantities. These are mostly used for calculations. Okay, these help the fundamental quantities define a physical quantity properly. Let's move on. And I did say that we'll talk about derived quantities a little later. So here we are with the derived quantities. We've seen what are fundamental quantities. We've seen the supplementary quantities. So fundamental and supplementary quantities, they work together to give us derived quantities. Okay, so let's look at derived quantities now. Derived quantities, as the name suggests, they are derived from fundamental quantities. Some of the examples you can see here: area, volume, velocity, acceleration, force, and so on. Yeah. How is it derived from fundamental quantity? Look at the third column, this column. This will show you how it is related with fundamental or base quantities. Okay, it's the same. Fundamental and base quantities are the same. Now, area, it's length times length. Volume is length times length times length. Yeah, if you remember the formula, it's length into breadth into height, but essentially length is of course a length, breadth is also a length, and height is also a length. Yeah, So that's why length into length into length. That gives us volume. Now, this unit we all know, the standard unit is meter cube. If you're measuring the length in centimeters, we'll get centimeter cube and so on. So this is how we get the derived unit. Let's take one more example, the example of velocity. Velocity is displacement upon time. How do we measure displacements? Displacement is also a length, right? Which is a fundamental quantity, length. And time is also a fundamental quantity, remember? So L upon T, length upon time. Length is measured in meters. If length is measured in meters and time in seconds, then meter per second is what we get. Meter per second is what we get as its unit. So go through this table once, pause the video, go through this table and see how we get derived quantities and their units from the fundamental quantities. Okay. Now let's move on to look at how different units developed, different system of units. Some of the names you can see on the screen: CGS system, MKS system, foot pound system, foot pound second system, and standard international system, SI system, or the international standard system. CGS is basically centimeters, grams, and seconds. Now, you can notice that the names of these systems are mostly based on three fundamental quantities. That is because, as we discussed earlier, when all this started, when we started organizing stuff, when the scientific community started organizing stuff, we had a certain amount of physical quantities. We already knew about those. And we thought that, okay, three quantities are actually sufficient to help us represent everything there is in the world. So, length, those were length, mass, and time. Okay, these three fundamental quantities. Wherever or whenever we were measuring length in centimeters, mass in grams, and time in seconds, that kind of system came to be known as the CGS system. Similarly, we have MKS system and FPS system. MKS system is when length was measured using meters, mass as kilograms, and so on. Yeah, foot pound system, as the name suggests, length and mass were measured in foot and pound respectively. SI system is actually a derivative of the MKS system. So we started refining the MKS system and finally we got the SI system, which is this last image that you see. Okay, so what was the story, or what is the story of development of different systems of units? Initially, three fundamental quantities were considered. As you can see, time here, I'll just move a bit and you can see, yeah, meter, that is length, and mass. These three quantities were being measured. These were a part of any system at that time. So that's how the names came. Then in 1946, a new fundamental quantity was added: current, as you can see here, ampere, measured in amperes. Eventually, as time progressed, we thought just these four quantities are not going to help us express everything that is there in this world, every physical quantity. So, new physical quantities, new fundamental quantities got introduced, and right now we have, so in 1960, till that time we had six, and now we have amount of mole also. Okay, so that's seven, total seven fundamental quantities we are dealing with, and those that set of seven fundamental quantities and the two supplementary quantities form the SI system. Okay, we have a couple of questions. Let's try to solve this with whatever we have understood.